And then we also worked on basic math skills to help them, especially those that are transitioning into the high school this year. So let me please welcome the Green Group and listen to their wonderful presentations. Thank you.
Hello, my name is Carlos Suarez, and this is the Tunguska event. The Tunguska event is an explosion that took place in 1908 in Siberia, Russia, from a mysterious object and from space. Studies have shown that the Tunguska event had the same effects as a 5.0 earthquake. The identified object landed and exploded in a forest area in Siberia, Russia, and the blast killed some animals and flattened 800 square miles of trees in Siberia. Here are some blast pictures right before the impact and the aftermath, so you can get an idea of what happens there. There have been a lot of theories over the past years, but here are the most three popular ones. One's a comet crash, a meteor crash, and a UFO crash. The more believable ones are the comet crash and the meteor crash because it can likely happen, while the UFO crash is less likely because it has to involve aliens. The Tunguska event today, after 106 years, there are still trees in the area till this day. There's a huge patch of grass where the explosion exactly took place, and the reason why the trees haven't grown back is still unknown to this day. Overall, there's always these three questions that come to people's minds. Why haven't the trees grown back? Can this happen again? Or can can this event, what exactly caused the event? Those are the three main questions that happened. And this is why the Tunguska event is one of the greatest mysteries that happen in our world.
Our presentation is on military cargo aircraft.
Arnella Person.
Oh, I'm Benson. It was used since the early 1900s. It was better than weapons used in the Civil War, and there was also Civil War that was altered. We had aircraft then because a lot of battles were won because of the field commander's ability to transport soldiers and supplies quickly and efficiently. One of the aircraft is the C-280 Greyhound. It's carry on board delivery, can hold 10,000 pounds, can go 300 knots to dropper, and takes 4 crew members to run it.
The second aircraft is the C-27J Spartan. It was owned by the Ohio Air National Guard, and it was used as an airland transport. First it was used for medical evacuations, but now it's used to transport supplies and people like food, medical supplies, medics, and paratroopers. The GRA, or the Global Range Aircraft, It's used to carry supplies to our troops in foreign countries. And it has a 280-foot wingspan. Um, Aircrafts today, they fly at speeds around 600 miles per hour, and if the GRA flew that fast, its wings would break off. In conclusion, all these aircrafts are a very important part of the U.S. today. Thanks.
Hello everybody, my name is Cesar Montiel and my presentation will be about the 3 laws of motion. The 3 laws of motion that changed the world. They were discovered by Sir Isaac Newton, and he discovered the law of inertia, which is the first law. But first, Sir Isaac Newton was a physicist and mathematician, and he was the best thing that has happened until Albert Einstein. The first law is if an item tends to stay in rest unless acted upon an unbalanced force, and an object in motion tends to stay in motion unless acted upon an unbalanced force. So meaning to say that if I was to roll off a pencil off the floor, it should keep going forever unless acted upon an unbalanced force such as the wall or the mic stand. Or if I left the pencil on the floor and no one touched it, then it should stay there forever. Newton's second law is the formula. The formula is F equals ma. F stands for force, m stands for mass, and a stands for acceleration. So force equals mass times acceleration. And there's a picture here showing how the rocket is informed by the law. The third law says for every action there is an opposite and equal force given upon. So if I was to run into the wall, I would be bounced back with the same force I gave to it, or equal. And that will be there. And there's a picture of how the engine is pushed forward because of the law. In conclusion, the 3 laws of motion changed how physicists looked at the world, or scientists looked at the world. Thank you.
My name is Peter Bord, and my presentation is on constellation. A constellation can be defined as a group of stars that is traditionally named after its apparent form or identified with a mythological figure. One of the earliest known images we know of is this statue of Atlas the Titan. He's holding a marble globe, which has some of the constellations the Greeks may have seen engraved onto it. In present day, there are 88 constellations that have been established by the International Astronomical Union. Constellations have been a big part of navigation as well, especially sea navigation. Seafarers at sea would use a sextant, which is a triangle-shaped navigation device, which they would point at the horizon and a point in the sky, such as a constellation, to get the angle. With that angle, they would be able to find their way around the sea. Also, in the Underground Railroad, slaves would use the Big Dipper to find the Little Dipper and the North Star, which is a set point in the sky, so it would be easy for everyone to follow. For a more in-depth look at a constellation, here's Leo the Lion. It was named after the Nemean lion, which was one of Hercules' 12 conquests. It had fur that was too sharp or too strong to be pierced by swords, so Hercules had to strangle it to death. Once it was dead, he took the body and threw it into the sky, where it became Leo the lion, which is the constellation Leo we now have. It is visible around the spring equinox between Virgo and Cancer, and is one of the 13 constellations of the zodiac. Thank you.
Hi, my name is Caitlin T, and my presentation is on the life cycle of the star. So, for the first is the birth of the star. Stars are formed in nebulas, which is like an area of dust and gas, and in that area, dust and gas come together to make a bigger object, and they start to collect more dust and gas to get bigger. After that is the main sequence, which is the yellow dwarf phase. During this stage is the gravitational force and pushing in and the nuclear fusion force pushing out is equal. An example of this stage is our sun. This is the red giant phase. There's no hydrogen fusion and loss of pressure, and then when hydrogen comes back to the star, it is blown off, like the layers are blown off and create a planetary nebula. And this is an example of a planetary nebula, which is just what's left. The last stage is a white dwarf phase, and the star will slowly lose its mass, and this is one of the closest stars to us, which is Sirius B, and is 8.6 light years away, which is about 50 trillion miles. Thank you.
Hi, my name is Charlie Dugler, and I'm doing my PowerPoint on the Northern Lights. The Northern Lights are discharged subparticles blasted from the sun's atmosphere and will interact with the Earth's magnetic field, are pulled into the Earth's atmosphere, and then interact with gas molecules. The different types of gas molecules determine the different color of the Northern Lights. The most common color, which is like a greenish yellow, is from oxygen molecules 20 miles above the Earth's surface. The next color, blue, is from nitrogen, and the most rare color, red, is from oxygen molecules 600 miles above the Earth's surface. During moments of high sunspot activity, the Northern Lights appear more frequently because sunspots are like dark spots on the sun, and there's storms and more discharged sun particles are spewed from the Earth's or the sun's atmosphere. Thank you.
My name is Nagi Sparja, and I'm going to do my presentation on the sun. The sun is a star. It's located in the center of our solar system. It's the heaviest object in our solar system. It's 100 times heavier than Jupiter, the largest planet, and 300 times heavier than Earth. Other objects orbit the solar system, orbit the sun because lighter objects orbit heavier objects, and the sun is the heaviest object by far. The sun has four main layers: the core, photosphere, chromosphere, and corona. There's an additional 5 more layers of the sun: the reactive zone, collective zone, sunspot, homocyst, and the solar wind. The core, reactive zone, convective zone, photosphere, chromosphere, and the corona all contribute to the sun's temperature and heat. The core is 15 million degrees Celsius. The reactive zone is 7 million degrees Celsius, and the convective zone is 2 million degrees Celsius. The photosphere is 6,000 degrees Celsius, and the chromosphere is 27,800 degrees Celsius, and corona is 1 million degrees Celsius. So the sun produces its energy by nuclear fusion, turning hydrogen into helium. So what this means is that since there's so much heat in the sun's core, nuclear fusion takes place and turns hydrogen into helium. And since there was already so much helium already at the sun's core, the atoms stick together and get energy is just charged throughout the entire solar system, and that heat is hot enough to reach Earth and provide us like a heat. So in conclusion, the sun is one of the most important things in our universe. It provides Earth, light, and heat, and for the solar system, it's one of the many classified things for a planet to become a planet for orbiting the sun. Thank you.
I'm Evan Y'all, and this is my PowerPoint about Pluto. Pluto is a dwarf planet, and it used to be the ninth planet from the sun. Because it's the farthest from the sun, it's really cold there, and sometimes it goes to negative 400 degrees Fahrenheit. And Pluto has a very low gravity, so if you weigh 100 pounds on Earth, you'll weigh only 6.7 pounds on Pluto. And Pluto has 5 rings. Pluto was discovered in February 1930 by Tombad. It was named by an 11-year-old named Venetia Verney from England, and she named it after the god of the underworld. But Pluto was declassified as a planet in 2006. This was because scientists made new classifications about what should be a planet and what should be a dwarf planet. They found Pluto to be in the Kuiper belt, not the same belt as the other planets, so that confused them. They were confused even more when they found Eris, another planet beyond it. Well, they thought it was a planet because it was 25% bigger than Pluto. But eventually they classified them both as Kuiper belt objects and not planets because neither of them could push other objects around the way that planets should. Thank you.
I'm Michaela Giles,
And I'm April Clayton.
and we'll be talking about Space Mission.
The Messenger. The Messenger is close enough to sense solar neutrons, which are created by solar flares. These solar flares live up to 15 minutes. If a solar flare is moving too slowly, it cannot be detected by the Messenger.
Pioneer Venus. They had contained 2 spacecrafts, the Orbiter and the Multirover. So the Orbiter contained devices used to investigate the Venetian atmosphere.
The Genesis mission. The Genesis mission Pathfinder was supposed to demonstrate a land and free robotic traveler, which was sent to Mars instead of landing close enough to the sun.
The Compton Grammar Observatory. It was the heaviest spacecraft of its time in 1991, and it was deorbited in 2000.
Thank
Thank
you.
you.
Hi, I'm Colin T. I'm doing my presentation on dwarf planets. What is a dwarf planet is the classification made when objects beyond Neptune and similar in size to Pluto were found in the area called the Kuiper belt. And some class requirements for it to be a dwarf planet is it can't be big as an actual planet, and it has to have enough mass so it can be spherical, and it has to orbit our sun. What's the difference between an actual planet and a dwarf planet? Is that normal planets are at least like 2 or 3 times bigger than a dwarf planet, and planets can be gas and rocky, unlike dwarf, which can be rocky and icy. Ceres is the nearest dwarf planet. It's in the asteroid belt. Account for 25% of the asteroid belt's mass, and has an icy surface. And some astronomers believe that there's an ocean under its icy surface because water vapors can be seen being released into its atmosphere. The Kuiper Belt is an area beyond Neptune. It is believed to have like over 200 dwarf planets within it, but we don't know a lot about it right now. And then there's the NASA missions. The Dawn is going to the asteroid belt to learn more about Ceres. And the New Horizons mission is going towards Pluto and the Kuiper Belt to study more about the dwarf planets over there. And in conclusion, I think the dwarf planets are something new that we still have something to understand about.
Hello, my name is Donna Mislick and my presentation is about Chorus 7b. Chorus 7b is the first rocky planet and the smallest so far discovered out of our solar system. Chorus 7b was discovered February 3, 2009. It got its name from a European space telescope named CORO. European scientists have been watching it dozens of times to make sure it is a planet and that there is land on there. But because of its temperature that is 4,500 Fahrenheit, it is made of molten lava. So it's impossible for any human being to exist there or any living thing. It orbits a dwarf star like our sun. It lives in a monoceros constellation, means unicorn in Greek. It has also a twin sister that also orbits the same star, but is much farther away and doesn't orbit as quickly, known as Chorus 7c. Chorus 7b density and diameter is very similar with Earth's, but because it's so far away, we can't get a current number, but by looking at it, they look very alike. And Earth's density is 5.52 grams per centimeters cubed, and the diameter is 1.58 times Earth. To get a better look at Chorus 7b orbiting the star, we can compare with Mercury. Chorus 7b orbits its dwarf star in 20 hours, while Mercury, that is the closest to our sun, orbits in 88 days. In conclusion, learning about Chorus 7b made us aware of the fact that there are other planets in the universe that we have never thought of, heard of, or could ever think of. Thank you for listening.
And I'm doing my presentation on stars. A star is a sphere shape with many different types of gases held together by its own gravitational pull. There are 300 billion stars in our galaxy in the Milky Way. Imagine how much there would be in a whole universe. There are the variable stars, which are the really bright stars which change each year. And the brown dwarf star is a really small star. And then the red giant star is, if you can imagine Saturn, the sun to Saturn, that's how big they can get. And then the white dwarf star, their hydrogen, they burn up all their hydrogen that was once used as a nuclear fuel. The neutron star is created when a supernova dies, and the black hole star is 15 times more massive than our sun. The main singular star, which is my personal favorite, if you can imagine there's over 1 billion, 300 billion stars in our universe. There are 90% of the stars are main sequence stars. And then there's very different many sizes of stars, and the M-type star is the second to the smallest because the brown dwarf star is the smallest. And then there's the largest star, which is the supergiant, which one of them is called the Betelgeuse. In conclusion, there are many stars in our galaxy. There are an infinite number of them. Thank you for listening.
A galaxy is a giant balanced system consisting of stars, stellar remnants, and an interstellar made up of gas and dust.
held together by gravity. There are three main types of galaxies. There's a spiral, an elliptical, and an irregular. The spiral has big arms that wind toward the center, and an elliptical just looks like an oval stretched out. The rest of the galaxies are irregular, so they can be any shape or size. According to astronomers, galaxies form by gases of clouds merging together and to form the building blocks of galaxies. There are so many galaxies in our universe that they cannot be counted. However, they have found out that there are approximately 100 billion in our universe. We live in the Milky Way, which is a spiral type of galaxy. It is 13.2 billion years old, and it has 300 billion stars. Our nearest galactic neighbor is Andromeda, and right now, Andromeda and the Milky Way are speeding towards each other at a rate of 27,000 miles per hour, and they are expected to hit in 3 billion years. In conclusion, galaxies come in many different shapes and sizes, and there are so many that they cannot be counted, but our universe is still expanding. Thank you.
Hello, my name is Stefan.
My name's Adon.
And this will be a brief history on airplane flying.
So airplanes originally came from the original people who flew airplanes were the Wright brothers, and 9 months after they flew the first airplane, they also did the first aerobatic maneuver, which was a 360-degree bank turn.
The two pictures you see behind me are of airplane evolution. And as years passed, not only did the airplanes evolve, but so did the maneuvers that they were able to do. They became more and more hair-raising, and soon, not only did it become a crowd pleaser, but also a sport.
So who was Lincoln Beachley? Lincoln Beachley was a famous air show performer, and what he was really well known for was his signature air maneuver, which was the death dip. And what he would do is he would fly 7,000 feet up into the air, and he would dive straight down only to pull up at the last second.
The real aerobatic pioneers were the barnstorming Americans and Europeans. And what barnstorming is basically when a group of aerobatic pilots come together at a barn and basically put on a gigantic air show for paying audiences. And they held these exhibitions in the 1910s and 1920s.
So fighter pilots that participated in World War I and World War II, they often used aerobatic maneuvers to win dogfights. And when they were done serving in the war, a lot of them often began second careers as air show performers. Thank you very much.
Hi, my name is Esperanza.
And I'm Santiana.
And we will be presenting the Halley's Comet.
The Halley's Comet was named after a British astronomer named Edmund Halley, who made a discovery of 3 bright comets between 1551 and 1682. Must have been the same one trapped in a gravitational pull.
Halley had made a prediction that the comet would return in 1758, but he unfortunately died before he could see his prediction come true. Halley's orbit takes 76 years, making it a short period comet, which means that its gravitational pull has been affected by giant planets such as Neptune, Saturn, and Jupiter.
When the comet was close to the sun, its nucleus would shed 7 yards of ice and dirt. Those fragments are known to be part of the Orion's meteor shower.
Orion's meteor shower is known to peak in mid-October and has been known as bright, quick fragments.
Those fragments are left behind by the debris that Halley's Comet leaves behind. This is a picture of Halley's orbit. When trying to see this comet, it depends on how bright it gets
how close it gets to the Earth, and when it passes our orbit?
Because Halley's Comet is on a tilted orbit, it would be hard to see it with just your eyes, so you'd have to use a telescope. Thank you.
Hi, my name is Naomi and I'm doing Neptune. So Neptune is 2.7 billion miles away from our Earth, and Neptune is the coldest planet in our solar system, and it's negative 218 degrees and has some of the worst weather in our solar system, with winds averaging at 2,400 kilometers an hour. Neptune also has a different time period than ours on Earth. A day on Neptune is 16 hours, 6 minutes, and 36 seconds, this making a year 16,920 days. Neptune's gravity is 11.15 meters per second squared, and that means that if you were to walk on Neptune, you would just sink in because Neptune is a gas planet and doesn't have a flat surface. Neptune also has 14 moons. The most interesting one is Triton, because Triton is the largest and is the only moon in our solar system that orbits the planet in an opposite direction. I also find this interesting because British astronomer William Lassell discovered this in 1846, just weeks after Neptune was even discovered. Neptune's gorgeous blue color comes from its cloud tops. The light we see coming from Neptune is reflected light from the sun with the red light stripped out. There are no firm plans to go back to Neptune, but they might send a mission out there called the Neptune Orbiter in 2016, which will arrive in 2030. Thank you.
Good evening, everyone. I'm doing the forces of flight, and I'm 20. So I've got an opportunity to visit the Museum of Flight during SAC, and I've learned that since the Wright brothers first flew in 1903, people have created a multitude of airplane types, but every one of them has dealt with the same four forces: lift, weight, thrust, and drag. A force is a push or pull that causes an airplane to undergo a change in speed, in shape, and in direction. A force has both magnitude and direction. Weight is a downward force of gravity and is always towards the center of the Earth. Its magnitude depends on mass of all the parts, the amount of fuel, then the payload on board, including people, baggage, freight, etc. Lift. The airplane's wings produce a upward force called lift that counteracts gravity. Lift is created by pressure differential around the wing. High pressure on the lower surface and low pressure on the upper surface. Low pressure is caused by increased airflow velocity over the top of the airfoil. Lift is an aerodynamic force. Aero stands for aerodynamic, stands for motion. Aerodynamic services is used to control the aircraft in roll, pitch, and yaw. The magnitude depends on the shape, the velocity, and the size of aircraft. A force called drag caused by air resistance tends to slow the airplane down. There are two types of drag. The first one is called parasite drag because it's not helpful in flight at all, while the second, induced drag, is a result of airfoil developing lift. The effects of the magnitude are the shape, the viscosity, and the velocity of the aircraft. To fight drag, the airplane uses a propeller or jet engine to produce a forward force called thrust. Thrust is generated by the engines of the aircraft to some kind of propulsion system. So in summary, lift opposes weight, thrust opposes drag. To keep an airplane at a constant speed in the air, lift has equal to weight and thrust has equal to drag. Thank you.